So in this class, we will see how the backpropagation is done in multi-layer artificial neural network. So we all know that multi-layer artificial neural network consists of one input layer and then one output layer, then one or more hidden layers. We will see the various steps involved in backpropagation. So in this, if you consider in multi-layer network, neurons are organized into layers and the edges are moving forward from the input to the output layer. And in this, we are going to use a method called as backpropagation. And this method is nothing but a method to fine tune the weights of the neural network based upon the error in the previous iteration. So in every iteration, we are going to compute the error. Based upon the error, we are going to update the weight. Then we will again go for forward propagation of the weights, and again calculation will be done. So the error propagate backward from the output nodes to the inner node. And with the help of this error, we are going to calculate the gradient of the error of the network with respect to the weight. So now let us see. So if you consider, we have two different movements in this. One is called as the input movement, that is nothing but forward movement. Here, we are going to send the weights to the next layer for computation. This is the movement in the forward direction. And if you compute this movement, it is nothing but in the backward direction, what we are going to send is errors. So in the forward direction, we are going to send the weights, whereas in the backward direction, we are going to send the errors. So because of this only, it is called as backpropagation method. So why we are sending the error is in order to update the weights only, we are sending the error. So this is the basic of the backpropagation, and what we are sending in the error term is nothing but gradient of the error. So you know what is the gradient? It is nothing but derivative. We will see that now. That only we are going to send during the backward propagation in the multi-layer ANN. So why we need the backpropagation now? We send the weights in the forward propagation. Why we need to send the error in the backward direction? Why it is required? Can't we compute the error directly? So if you see, as we know the actual and the predicted value at the output layer, we can find the error. Because in the output layer, we know the actual value. That is nothing but when you give the training data set, at that time itself, you will be giving the actual value. And in the output layer, you can also calculate the predicted value. That is nothing but value generated by the model. Okay, in the output layer, we know both these values. Since we know both these values at the output layer, we can calculate the error term by subtracting them. But we cannot find the error at the intermediate hidden layers, because in the intermediate hidden layers, we don't know what is the input and what is the output. That is nothing but we don't know what is the actual data expected at the hidden layer and what is the data generated by the model. We don't know those values. Only at the output layer, we know what is the actual value expected. In the intermediate layer, we don't know those values. So in that case, how to update the error? So for that only, the error at the output layer is due to the errors in the previous hidden layers. So from the output layer, we backpropagate the errors to the hidden layers. So from those hidden layers, again, the errors will be backpropagated to the previous hidden layer till we reach the input layer where we will be doing all the weight adjustments. So this is the basic idea of backpropagation. So this slide is explaining you why we need the backpropagation. So only at the output layer, we know the actual value and the predicted value, so we can calculate the error term. But in the intermediate hidden layers, we don't know what is the actual expected value from the hidden layers. So because of that only, we cannot compute them directly. We need to go for only backpropagation. So in every layer, you are going to backpropagate the error to the next layer. Not the next layer in the sense, next layer in the backward direction. Okay, when I show you the slide, you will be understanding. So in this, we are going to use something called as cost function. Cost function is nothing but it is a function that measures the performance of the model for any given data. And here, the cost function is nothing but we are going to consider the error function only. Okay, so this cost function quantifies the error between the predicted value and the expected value from the model. So now, let us see another important term called as gradient descent. So gradient descent is nothing but here, if you consider this particular graph, I have plotted the graph between the weight value and the cost function. So what is cost is here? Cost is nothing but error. Always we need to minimize the error. It is an optimization problem. In some optimization problem, we need to maximize something. If it is the profit, we will maximize it. But here, we are calculating the error only. Error, we always want to minimize it. So we are plotting the graph between various weight values and the error. That is nothing but the cost. If you consider, if you increase the weight value, let me see this particular point here. I am assuming that I have my point here. So in this cost is very high. That is nothing but the error is very high. I want to reduce the error. So what I can do is I can increase the cost value. So I can increase the weight value. You can see in the x-axis I have the weight. So I'm increasing the weight value and moving like this. When I increase the weight value, my cost is reducing. That is nothing but error is reducing. Fine. So if that is the case, can I go on continuously increasing the error? It is not possible. If you consider at a particular point of time, for certain weight value, the error will be minimum. After that, if you still increase the weight value, the error will be increasing. Okay, so we are getting a curve like this. Okay, so what is our aim is we want to find this particular part of cost. Okay, so here only the cost is minimum. After that, the cost is increasing. Okay, so what is our aim is we need to find the minimum cost. The minimum cost is having certain weight. That is nothing but this particular weight. Once you find the minimum cost, find the minimum weight corresponding to those costs. So this is the weight you have to use in your model. Okay, so we cannot learn this in one iteration. It will take so many iterations to learn the optimal weight. Okay, so our aim is we need to learn the optimal weight. Optimal weight corresponds to the minimum cost because cost is related to error. So we need to find the optimal weight now. With the help of gradient descent, we are going to do this. So find the value of the weight such that error becomes minimum. And if you consider this particular curve, at any point on the curve, the gradient will tell you how steeply the error will be reduced or increased for a change in the weight. So what is the meaning of this statement is, I am going to consider this. This is my initial weight. Okay. So what I will be doing is I'll be incrementing the weight by a small value. So I'm doing incremental step only. By small weight only, I'm going to increment the weight or otherwise decrement the weight. Anything will happen here. Okay, so in that case, what is going to happen is when I change the weight by small value, there will be a change in the cost function also. Okay, so that I am going to compute. So this gradient will tell you, gradient is nothing but the slope of this particular curve. For this curve, you are going to take the slope at this particular weight value. Okay, so at any point in the curve, for a particular weight value, you can calculate the slope that is called as gradient. That is going to tell you by how much you can reduce the error. So compute the gradient or slope, which is nothing but the first order derivative of the function at that particular point of time. For every weight value, you compute that. Then you're going to move in the direction opposite to the gradient to change the weight value. That finally, that will result in greatest reduction in the error. So our aim is you compute the gradient and then with the help of that, you update the cost function. And that is nothing but you're going to update the weight.